Hello everybody and welcome to today's webinar. Today's topic is linked open data for cultural heritage, and our lecturer is Vladimir Alexiev, who has amazing knowledge on this webinar, so I'm going to keep myself short and just give you more he will give you more information. I want to just share with you today that this webinar is being recorded and you will receive all the video as well as the presentation after this webinar. You're also going to receive all the questions that have been given today. If you have any questions that are not answered, you'll also get the answers afterwards. We try to be very extensive with those, so don't worry, you'll get all the necessary information. Also, the presentation has links that are clickable. You'll receive those as well. Today's webinar is approximately 1 hour, 1 hour and a half, so sit tight and enjoy it. If you have any questions, please ask them in the Q&A panel, which you can find at the top right corner of the screen, and ask us your questions. Vladimir will try to answer them as many of those as possible at the end. Thank you again for the patience, and now Vladimir is going to start his amazing presentation.
Hi, thanks for the introduction. I can certainly say it's rather long. Whether it's amazing, that's up for the audience to say. First, I'll say a few words about myself. I've been in IT for about 30 years, one of the founders of Schema Group Holding, which is Bulgaria's largest software group and the parent company of Ontotext. I did a lot of project management, business analysis, and data modeling, and some of them for big projects. I have a PMP certificate and a master's and a PhD degrees in computer science. But in the last 8 years, I've been focusing more and more on data modeling and data analysis and so on. And in particular, the last 6 years after I joined Ontotext, semantic data and semantic integration, in particular in the domain of cultural heritage. So I guess you can call me a bit of a data freak. I like to get in depth with various kinds of data, understand it, and also understand how it can be linked to other data. Something important that's related to the presentation is my publications list. I'll show it just briefly. Right now it's sorted by keyword. So let's say if you're interested in the SeeDoc CRM, there's all the papers and presentations that I have on the topic. You can also here on top group it by, let's say, year and see recent stuff and so on. There's links to published papers, preprints and presentations. The abstracts are also available, the BibTeX records and so on. So if there is a topic that interests you, please go through the publications list and check it out. I'll try to go quickly through the slides. Some less important slides I might just skip. But also I had a bit even more slides on library topics. I decided to omit those for reasons of time. But when I publish this, I think I'll publish a second version that also includes library metadata and library ontologies. Okay, the presentation is structured into, first of all, 3 sections that talk about GLAM data in various incarnations. Also GLAM datasets, this is in section 5. And then in section 6, which unfortunately you cannot see everything here on the screen, I'll talk about a number of projects in this area, both Ontotext projects and others projects. Okay, so let's start with what is GLAM, what is cultural heritage, what is digital humanities. Cultural heritage is something very important to many people. It relates to our ancestry, who we are, to our nationality and to art and so on and so forth. It includes both old and new forms. For example, quite interesting topics are how to describe and preserve digitally born material, or let's say tangible versus intangible, such as various national folk traditions, or let's say the performance of a ballet. How exactly do you record this in terms of data? And these different institutions, galleries, libraries, archives, and museums, or GLAMs for short, even though they have their own emphasis and ways of organizing data, they all work in this very interconnected domain, which is cultural heritage. Digital humanities, well, it's the use of computers in the humanities. It's not really a new branch of science. It's been around probably for 15, 20 years. People using computers to analyze text for a long time. And here's just some example of a few UK universities with very strong DH programs. These are the Twitter accounts. Now let's take a look for a while at popularity. So here I have taken a chart from Google Ngrams, which is phrases or words that appear in books by year of publication. And you see that libraries and museums in books, they appear quite a lot more often than Google, Facebook, and other internet properties. But if we take a look at two specific institutions, let's say Facebook and the British Museum, we see that in recent years, interest in Facebook in books has spiked and it has surpassed interest about the British Museum. More importantly, if we take a look at search trends, in other words, what people search for on the web, this is again from Google, the picture is completely reversed. Facebook is on top, libraries and museums are somewhere there on the bottom. So the upshot is that a GLAM that doesn't pay attention to the web and the internet is pretty much doomed to extinction. Perhaps teenagers with smartphones are going to have the best of such GLAM institutions because they will not go to the library to search through the library catalog. They want to be able to find everything they need using their smartphone on the web. So even if the library has an online catalog that is accessible through the web, still the library needs to think about exposing that information to Google so that Google can index it. In other words, GLAMs really need to turn the internet as part of their modus operandi to really subscribe to it and use it in their daily operations. And I can mention here these three acronyms or numberings. Web 1.0 is about presenting information. Web 2.0 or the social web is about interaction. And Web 3.0 or the semantic web is about data linking, enriching text in order to connect it to some global databases of entities, people, or places, and so on. And it's interesting that the same person who invented the web, Sir Tim Berners-Lee, also envisioned the semantic web, and that even happened in his original proposals to CERN. So he didn't only talk about the web of hyperlinked documents, but also about the web of data. Why is linked open data or semantic technologies important to cultural heritage in particular? First of all, because culture is inherently interconnected. It transcends national borders. It goes across institutions, across languages. And it allows to make connections and really to make sense of information across institutional boundaries and across object artifacts and so on. Also, linked open data enables large-scale digital humanities analysis, retrieval, searching across collections, and so on. Now, in the next three sections, we'll look at various aspects of GLAM data. We start with the so-called GLAM content standards. Because GLAM data is complex and varied, professional bodies like, let's say, the International Council of Museums or the ICA, International Council of Archivists, find it useful to first of all define standards about what information should be captured about objects before describing how it physically should be laid out. And for me as a data analyst, these standards are also very useful because they include nice examples, and really the examples elucidate what is in the data and determine the semantics of the data. So I start with the CCO standard, cataloging cultural objects. This is about museum objects, art and architecture, and so on. It's driven by the Getty Research Institute, and I'll have several things more to say about Getty later on in the presentation. So here is an example from the CCO. On the left is the work record, and on the right, the personal authority about one of the creators of that work, with a link between them. So you see the richness in information that the standard recommends should be captured. For example, take a look on the left at this creator display in the two rows. It captures not only the main contributor, Marco Ricci, but also somebody who did the figures on this painting, Sebastiano Ricci. And similarly, for the person record, there is a whole lot of information, places, events, dates, and so on. Next up is some more complicated work of art, namely the portal of the Chartres Cathedral. And in this case, there would be a connection, a hierarchical link from this object to the parent object, the cathedral itself. Finally, from CCO, a description of one particular data element. Creator extent describes to what exactly contributor has contributed. So it could be to the design of something, but not, let's say, not the building or the adornment of it. It could be to the predella or figures, illustrations, and so on. This richness of information is required by art history scholars to make connections between works of art and between artists and so on. Next up is Spectrum, which is a UK museum management standard. It doesn't only cover data, it also covers procedures. For example, the most important procedure is object entry. When you receive an object, how a museum is supposed to catalog it, which parties have a role in this process. Also, Spectrum addresses accreditation or certification of IT software against this standard. Here's an example of a Spectrum procedure, object entry, and you see the different roles and the different steps in the process that the standard recommends. I'll have more to say about Spectrum data later on. Regarding archives, they have a set of 4 international standards, and of course, before these international standards, there were national standards, let's say by the Society of American Archivists. This here is by the International Council of Archives, ICA. As you see, these standards typically go through a number of editions over a number of years. And archives talk about archival materials and then agents who create or use these records, corporations, people, and families. Functions are roles that an agent can have in an organization. And finally, the archival institutions themselves. In the next section, we'll take a look at several GLAM metadata schemas. These are usually XML schemas to describe the information, the physical format of the information. And here I would recommend a publication called Seeing Standards. It's a list of acronyms about standards and the brief categorization of the standard is about. And as you see here, it covers a whole bunch of different areas, including type of media, type of content, the type of institution, and so on. This is the full Seeing Standards poster, but when you access the PDF, you can deep zoom into it and see the standards and some information to them and so on. A few words about XML schemas. I would highly recommend that rather than the most popular way, which is XML schema, you should consider using RelaxNG. It is as powerful, actually more powerful than XML, but the form RelaxNG Compact or RNC is the best way to read and write XML schemas. Here's a couple of links for tools that we have for this, and on the bottom is a screenshot from my editor, Emacs. So you see the syntax highlighting, indentation that shows the nesting of the schema, and on-the-fly syntax checking. This where junk doesn't belong there, so the underscoring shows me that. We'll start with something called Categories for Description of Works of Art. It covers the CCO standard, Cataloging Cultural Objects. It's a rather big thing with 530 categories or data elements. This means attributes, elements, and the nesting, the grouping of elements within other elements. And it covers these 22 different pieces of information. Each of it is nested about artworks, basically. Here is a brief listing of part of CDWA Lite, which is a specific XML schema that covers CDWA. Next up is Kkona. Kkona is the Getty Museum Data Aggregation Initiative. It stands for Cultural Objects Name Authority. And the Kkona schema is an intermediate XML schema, so every museum's contribution to Kkona will be converted to this before being ingested to Kkona. You see very well here the nesting of the schema, and it's quite understandable, relatively small, 280 elements. Next up is the Spectrum schema. It is much bigger. It has almost 600 fields and 10 types of entities. The most important entity is the object or artwork, and it has a whole lot of fields, almost 500. But unfortunately, I don't know of anyone practically working with this XML standard. LIDO, or Lightweight Information Describing Object, is an important XML standard for international museum data aggregations. So some projects use that to gather data before converting and submitting to Kkona. And these are the different sections that LIDO covers. It was inspired or evolved from CDWA and the German standard called Museum Data. Here's an example of a museum object on the left, as you see on a museum website, and the corresponding XML information with its nesting on the right. Typically, this was borrowed from CDWA. You have display fields and indexing fields. So you see here display object measurements versus the indexing fields. The reason these are recorded is because they often include additional nuances that a museum curator would enter that are not needed in the indexing part. Regarding archive metadata, there are 3 very well-established XML standards for archival descriptions for agents, which are corporations, persons, and families, and finally for archival institutions. I won't have time to go through this, but we work quite extensively with EAD in the EHRI project, Holocaust research, that I'll mention later on. One problem with the archive metadata standards is that they pay more attention to presentation. In other words, they have tags similar to HTML to be able to format the information out through printing, but they don't care so much about linking, identification, and so on. So, for example, you cannot identify a person by a URL. You can structure events, let's say in this chronological list, but only there's a separate field for the date. You could tag out the person names, but you're not required to, and many institutions just don't do it. And furthermore, here, the relation that Sam Voss name was the successor and John other name was the predecessor, the relation is not explicitly stated. Also, the simple strength of linked open data is that instead of just names, these people would have URLs, be that ISNI URLs or VIAF and so on. I'll talk about VIAF later on. And this takes care of ambiguity. There could be many people named that, but the URLs make things unambiguous. Okay, in the next section, we'll take a look at several semantic data models or ontologies for the GLAM domain. First, just one word about RDF and why people consider it to be a more abstracted format, and why they say when you convert to RDF, you're listing the information, and when you convert it back to some other format, you are lowering it. Well, RDF is a graph data model, and even though there are many different syntax renditions of that model, Actually, RDF XML is probably the worst of them, even though it's the first one and the standardized. But there's Turtle for readability, there's JSON LD for easy consumability by program, but really what it represents is a graph, and you can query that graph, navigate it, and so on. So it doesn't force you into putting your information into hierarchical form like XML does. I'll start with the Europeana data model. Europeana is the European aggregator. It has collected 53 million objects to date. Same model has been adopted by the DPLA, Digital Public Library of America. This is a relatively simple standard. You see it below all of the classes. So really the payoff is doubling core. So it has things like creator, publisher, extent for measurements of the object, and so on. It also uses scopes to capture things like concepts or agents, the name of an agent. And it does have events that are inspired from SeeDoc CRM, which I'll talk a lot later on. But events are still not really represented. So here is an example of one particular object. This is a Bulgarian national treasure. In the middle is the so-called cultural heritage object, and on the left and right are two pairs of so-called proxy and aggregation. These represent information from different institutions about the same object. This is a sort of complication of the model that many people don't really understand why is it necessary. But the important thing is how many of these fields here are pure text versus how many point out to other data sets. So let's say this year's subject, history, is not so good, but that subject which is a link to something where you can find, for example, other objects with the same subject, that's better. Some issues with EDM. I mentioned about these complications. Data providers provide this format, EDM external, whereas upon ingesting Europeana, it's converted to this more complex thing, EDM internal, with two pairs of aggregation and proxy. On the other hand, it's not expressive enough. For example, you cannot capture the particular contribution that the person had. You could have a Lindsay contributor, but you cannot say this is the printer, or he painted only the illustrations, or he did the figures in the top right. That's not possible to do. But it is still evolving and being extended. I was at a workshop where we, related to the Europeana Data Quality Committee, we suggested that events really need to be implemented because they allow you to capture this connection of contribution, relation between agent and artwork. Next up, the SeeDoc CRM. SeeDoc is the documentation committee of ICOM, the International Council of Museums. It's also an ISO standard, but it is still evolving. It's not a very big ontology for the scope of work that it tries to accomplish. So there's about 85 classes, and it has some important fundamental splits. So first of all, you have here persistent items versus temporal entity. These are the two main branches of the class hierarchy, or these are also called endurant versus perdurant. And amongst the persistent entities, you have physical things, such as a work of art or a physical document, versus conceptual objects, such as what is depicted on the artwork, or the text of the document as something that you can copy or transcribe many different times. One also important thing about the CRM is the event orientation. You see that the temporal entity is the important part of the TED hierarchy is event. Why is that important? Because the only way to relate dates and places and objects and agents is through events. You don't have a field created on, rather you'd have a creation event that would have a time span, but in the same creation event you can put extra information. Who did it, where it took place, and so on. This is the CRM property hierarchy, so sub-properties, you see the dashes here. So this here property is a subproperty of this one and that one and that one. There's a 4 times inference prescribed for this property here. It has about 135 properties, but they're inverses as well. It's somewhat hard to get the understanding of. It's a bit complex ontology, but I think it has fundamental importance for the GLAM domain. One very important resource, together with the SeeDoc CRM tutorial, is this graphical representation of the CRM. So it consists of situations like this. Let's say here we're talking about a thing, and it could be a work of art or a natural piece, let's say a rock in a pathological museum. And we're saying that this thing has a dimension. The dimension is described in a structured way. So it has a value, let's say 60. And it has a unit, let's say centimeters. And it also has a kind, P2 somewhere there should be. So you have to describe what you're measuring, right? Also, a fundamental concept is shortcut versus long path. So here we could say directly that the thing is this dimension, but we could also say that the thing, this here double arrow is inheritance. So this property, it applies not only to the root E1 CRM entity, but also to every subclass thereof. So the thing was measured by a measurement activity, a measurement event, and then the measurement event observed that dimension. But here in the measurement event, you can put a whole lot more information. Who measured it, when, what techniques they used, what is the tolerance, and so on and so forth. So this allows you to describe the information in briefer ways or also in more elaborate ways. Another important ontology, even though it is not limited to the GLAM domain, is web annotation. It's also, for example, used quite extensively in the scientific research domain, in particular in life sciences, biology, and so on. So it allows you to capture in a structured way comments about some piece, let's say paragraph or a whole article, connections between resources, let's say the citation of one article by another, or just bookmarking, that also you can capture using open annotation. And here is an RDF graph representing the complete example, number 44 from the specification. I cannot torture you to try to read it, but basically there is an annotation here, and it has a target. This is the thing that we are talking about. In this case, we're saying it is a specific resource. In other words, it has a selector, and the selector has an XPath. So presumably this is an XML document, and we are digging down into the document and talking about one particular paragraph of that document. And on the left side, this annotation has two bodies, one branch going down here, and another body which is a simple textual body. So in this silly example, somebody says, I really love this particular bit of text in that XML document. It's a very, very powerful ontology, and it is gaining fast popularity in all kinds of areas. Next up is the IIIF. It also is gaining speed and popularity, in particular in the GLAM domain. It's about images, in particular deep zoom or high resolution images, which are very important for works of art and for manuscripts and things like that. And there is a very nice site with the showcase and access to all of the specifications and so on. As part of IIIF is something called Presentation API, or also called Shared Canvas. So imagine a blank piece of paper, and then on it you're putting some transcriptions. You're also putting two images on top of this blank, but in this case we're saying, well, it's choice, it's exclusive, or either the X-ray scan of this manuscript or the visible light photo of this manuscript. You could also sort of switch between them and compare. And this is very important for manuscript researchers because quite often pages are split between different institutions. Even scraps of the same page could be in different institutions. So this allows the virtual putting together of manuscripts that are hosted by different institutions across the globe. It's very well described by Rob Sanderson, who is now the semantic architect at the Getty. He was with Stanford before that. And it puts a lot of emphasis on JSON LD, which is a format that's useful for programmers, so they don't have to dig into the RDF or semantic web nature of this. They can just write easily clients using these standards. Next up, archival ontologies. So there has been several attempts to represent the encoded archival description XML as RDF, but I think the more important, very recent development is this new Records in Context initiative by the ICA. So they have released a conceptual model that sort of merges the three previous standards, EAD, EAC, and TAG, and addresses all of them. And they are currently looking for comments. After finalization of this, they will turn out to convert that into an ontology, in other words, a semantic web data model. Here is just one example from Records in Context. So here on the right, in yellow, it's some archive materials, and on the left are some agents and functions that created these materials. And this gives you the provenance of the fonts. This gives the fonts with the hierarchical structure that is familiar from EAD. So, from fonts down all the way to individual items. And really, if you think about the nature of this information, it really is a graph of different pieces of information. So it's very well tailored to semantic representation. Okay, the next section, I'll talk about several different data sets that work with, that have to do with GLAM data, or there is now a hashtag and a whole series of conferences by biannual conferences called LOD. So here you see a diagram which we recreated based on work of Michel Hildebrand. It shows some of these databases, for example, the Getty Thesaurus of Geographic Names, the ULAN, Unified List of Artist Names, with the connections between them, and then some sort of related data set. So let's say this one is people described by the Rijksmuseum, or this one is the same sort of information used by the Louvre. So there is an analog of the Getty AAT conceptual thesaurus called Kkona. And as you see, there is a linked open data cloud of LOD information that is about cultural heritage emerging. What you don't see here is large-scale collections, such as Europeana and the British Museum and so forth. And I think Ontotext is lucky to say that we're somewhere in the middle of. We have worked with the Getty Thesauri, we have worked with these datasets here. I'll describe that later. Now, a very, very interesting development in the last, I guess, 4 years, but really picked up speed in the last 1.5 years is Wiki Data. Wiki Data is also sponsored by the same foundation that does Wikipedias, the different language Wikipedias. And the idea there is to collaboratively edit facts. So, for example, here are some facts about this painter, Franz Hals. First of all, take a look at all of the different identifiers in different authority systems. I'll speak more about this later on. This is only maybe a quarter of them. Then there is factual information, like his family network, mother, father, children, and so on. And later in this page, you see paintings by that person that are also registered on Wiki Data. maybe who he influenced or who he was influenced by. But there's also some generation of natural language from the facts. Here you see labels, names of this person in a gazillion languages. I will again have something more to say about name data sources. Here is genealogy based on Wiki Data, the family tree of Barack Obama. So here is Barack and here's Michelle, and they are a married couple. These are their two daughters. We can see that Barack Obama Sr. was Barack's father, and so on and so forth. And all of this is from information in Wiki Data. There is a very interesting project on Wiki Data called Sum of All Paintings. What are Wiki Data projects? Very usefully, they don't use separate data infrastructures. These are just initiatives to aggregate more data in a particular domain, or to clean up fields, to create hackathons to capture more data of particular nature, and so on. So here is an example. You can call it a catalogue zone. Paintings by Franz Haus in different institutions. And because all of them are on Wiki Data, it's very, very easy to capture this sort of white box display. Here's an even better application called Krotos. I highly recommend it. You can search by periods, you can search by names. It does autocomplete. You can search by the relation of that person to the painting and so on. And as you see, Wiki Data knows quite a lot of paintings by him. Here you have links to Wiki Data, Wikipedia Commons, the original Wikipedia that it came from, and so on. Most importantly, everyone can help in the building of Wiki Data. It's not hard at all. So, for example, there is a current drive by the Sum of All Paintings project to add inventory numbers to paintings. Why? Because this is used for identification of paintings. If you get a new data load from a museum, you don't just dump it onto Wiki Data. First, you try to identify maybe there's already records and you just enrich those records. So I dug down into the US. There's 1,000 paintings with missing inventory numbers, and then found 2 in the Getty. And let's fix the second one, this painting by Manet. So you just go into Wiki Data using this link, okay, the link of the painting. Well, of course, you need to do some digging on the Getty site to find the painting, find out the object number, enter it here. Also capture the URL on the Getty site using this property. And entering all of this is rather easy. I have a presentation cited later on. GLAM's working with Wiki Data. It has excellent auto-completion. It really is easy to use. And there you have it. We fixed one of 10,000 paintings that need an inventory number. Historypedia is quite a nice GLAMy application, creating really nice looking timelines of stuff. For example, paintings by Leonardo. And you can zoom in, see more paintings, see more information about every particular painting, put them in a better layout that you like, take a screenshot, share it, and so on. Next up is VIAF. It's a very, very important resource, stands for Virtual International Authority File. It was initiated by 3 national libraries, and now there is 20 libraries as contributors and 10 other important institutions, including the Getty, ULAN, and Wiki Data. So here you see a cluster of names about Spinoza, or rather I should say the different records in different libraries about this person. So this, for example, here is the Spanish National Library. And this both gives you a whole bunch of extra names, and it could also give you different points of view about the facts of the person. Some of the national libraries could have a different opinion about the life of that person. Here's a quick comparison of relative sizes. So Wiki Data has 14, or I think it's maybe 17 million objects by now. These are This is the union of all of the objects described on the all of 280 national language Wikipedias, whereas VIAF has by now probably 35 million objects. Also, you see that VIAF has 26 million persons, whereas Wiki Data has only 4 million. But of course, the data that you see in VIAF is less, just names and dates of birth and link to bibliography in WorldCat, whereas in Wiki Data you have connections to the different Wikipedias, and for famous people like Obama you can find everything about him. Did you know that Obama has a Grammy? Yeah, I wonder if it's easy to find an award that Obama doesn't have. Now, the topic of global authority control, so there is a kind of a movement in last year towards global authority control, which really is a dream come true for a librarian or an authority metadata specialist. I did a technical report or deliverable for Europeana called name sources for semantic enrichment, and I looked at 7 different data sets, and I found that they are dominated by VIAF and Wiki Data. So some of the data sets, they come from the library tradition, and most of them are aggregated in VIAF. And others come from link open data tradition, and they're dominated by Wiki Data. The size comparison in the previous slide, I also described there. And on the next slide, you see a Venn diagram from this study. So I checked all of the different names of Lucas Cranach in these 7 data sets. There's about 135 names for Cranach. The library data sets, which is VIAF here and ULAN and so on and so forth, they have more name forms, whereas the Wiki Data and DBpedia and Wikipedia, they have more translations in different languages. Surprisingly, there's little intersection, which really is good because now you have more name forms. Furthermore, by using this cross-referencing, you can enrich both VIAF and Wiki Data. For example, Arkady Art, Arkady is the Dutch Art Institute, a very important institution. It is still not part of VIAF, but by using the Wiki Data identifier, it could quite easily be imported into VIAF to complete the co-referencing. Furthermore, once you have the co-referencing between different data sets, you can complete data from one to the other, things like birth dates and so on. Wiki Data has created an excellent tool for matching authorities. It is called Mix and Match. It's also very easy to use. By now it has 235 catalogs or authorities inside. So for example, when I have some free time or I'm just bored with my real work, I go into the AT catalog and just do some more co-referencing. You see here that about a quarter of it is matched. These bluish things are match suggestions that are not yet vetted by people. There's also some catalogs that are now complete. For example, the Australian, these are important Australian people, but this is rather smaller. This is probably 10,000 items, whereas in ULAN you have over 200,000. And of course, this takes a lot of work, but there's automatic tools that match suggestions, and there is the power of the crowd. Here is how to work with the co-referencing. So in the AT, I just said, yeah, this pyrroluzite, which is an inorganic material, yeah, sure, it's a whatever mineral group, looks like the same thing, didn't even have to open any of the records, check, is the same thing. Whereas this here stone masonry versus the matching Wiki Data with stone mason. One is a process, the other, or technique, the other one is the person doing it. It's not really a good match, I removed it. very fast to work with. Okay, finally we are down to the interesting section, LOD projects, and I cannot really do justice. There is such a wild variety of projects, and they're so interesting, and so many people do projects in this domain that I couldn't even hope to describe the different kinds, let alone describe all of them. If nothing else, if you don't know this work, you can learn a new word today, prosopography, and it's the study of microbiographic information that you can find in various original documents. Or I really liked how this project called it prosopography. This is really the Facebook of ancient times. So I think I have a slide towards the end on studying ancient charters. Charters were like the notary deeds of old. And on these pieces of paper, you have important list of names. For example, the witnesses. This tells you people who lived around that neighborhood in that particular year. Or even if you don't know the year, you know that they were at the same time. So you can now start making conclusions about the connections between these people. I'll start with some projects where Ontotext was involved, and then I'll finish with some projects by other people if I have time. Okay, let's move on. So first, the Andrew Mellon Foundation. It's an important funder in this domain. It mostly funds digital humanities projects or art research, but it also funds a few software development projects. And there is this set 4 called the Space projects. Collection Space is for creating a museum collection management system. Archive Space is similar for archive management by merging the 2 top open source systems. Research Space is an environment for art researchers using SeeDoc, CRM, and various tools. Ontotext was the initial developer on this. Conservation Space is a core line of business application for conservation workers, and it is still being developed by a sibling company of Ontotext. I have a slide about it. Research Space, I have several slides, but I'll go quickly through some of them. So first of all, it has a semantic search. Here we're looking for objects from London that are made of paper, and you see some prints here and some drawings. When you start typing London, you have an autocomplete, so you will pick the exact place that you mean. And this here from, behind this brief word, there is a whole network of concepts. I'll talk about this in a second. There's also faceting on the left, so you see how many different object types. There is 7 calligraphies, 1 broadside, and so on. You see a breakdown by creators and so on. Another search gives me things that are created by Rembrandt, that are drawings, and that are about mammals. And indeed, we see here some drafts by Rembrandt of pigs and horses and so on. How does it know that pigs are mammals? Well, easily. There is a hierarchical structure to that thesaurus of concepts, and it says that pigs has a broader concept, whatever which has a broader concept mammal. How is this search implemented? Well, it uses an idea by one of the main creators of the SeeDoc CRM, Martin Dorr, called fundamental relations. The idea is that if you want to look at these four types of things, what, who, where, and when, and if you make a matrix, and if you analyze all of the different relations that could exist between these, then you have this whole bunch of relations. And each of these relations can be realized by a different alternative network in the SeeDoc CRM graph. In the next slides, I will only focus on this here, from, more particularly think from place. So this captures the idea that a thing could be said to originate from a place. Here is such a network, and it describes the different alternative paths. We could say that the thing was used in an important activity that took place in that place, or it was created this year, beginning of existence in a place, or it was created by a person who is currently located in a place, or who was born in that place, or who is part of a group that is headquartered in that place. And just think that you also have these recursive relations or part of relations. So maybe you're not talking about the whole object, but about a significant piece of it. And here we're not talking about this particular place, but a subplace thereof. This allows you to search for, I don't know, objects made in India and find objects that are cataloged. The creation place is a small village in India, or that the creator was born in that place. Now, implementing this is rather a challenge, and we did this as part of research space using GraphDB rules, about 120 rules. And this here is just the dependency diagram of different properties and how we build them up in the inference. So, for example, this grayish property, which is an intermediate result, it feeds from this property, but also from this source property. There's an inference rule that produces that. There's a recursion on the rule, and after that it feeds into this and that and that and that. Quite an engineering feat, I tell you. There's a paper about it. Look for research space or CRM and you'll find. Now, after the end of our involvement with research space, the project continued and a new version of the search was implemented, much better UI, but the same basic ideas. You have the different fundamental entities that you can search for. You have here building up one condition for the search. So here we're saying created at India, but before that we already said created within a certain period, and we selected the type of object paper. And again, you have the facets on the left. Please watch this video, it's very nice, gives you a whole overview of how you can save searches and relate an object to a saved search of places and various niche tricks like this. Back to the old research space, we also had something called data annotation. So, for example, about any one of the pieces here, you could state a different opinion, select a different data value, or enter a comment. And this is how we modeled the information, basically using RDF reification, but also somehow merged with the open annotation standard. When we were working on this, the open annotation was not yet popular and not even done. I mean, there was some initial drafts. Then we also have image annotation, and we merged two things here. One is a free drawing over an image, so you can draw different type of shapes or regions, and also deep zoom image. You see the scale here. So this is a high resolution X-ray of some painting, and we're putting a particular region here, and then we can again connect to specific concepts in a thesaurus or just enter a free text. This allows very rich description of information. Here's the data model for image annotation. For that one, we used open annotation. It has body and has target. The target in this case is a particular image, a JPEG, but we are saying no, it is a part of that image, namely just this region, which is described using SVG. You see here the properties and the content of that SVG. And on the left side is whatever comment or link we want to make. This is the pieces of software we used: IP for deep zoom, SVG edit for drawing the shapes, and we put them together. Now, as part of Research Space, we also helped the British Museum convert its data to link open data, and for a number of years it has been the biggest museum data set in RDF. It is in SeeDoc CRM. There is a publication describing how it is done, and volumetric information and speed information. And also, maybe you have seen this diagram in presentations of Dominic Oldman. There is a very detailed description of the mapping. Unfortunately, it's a monolithic. In other words, it doesn't allow other people to contribute or make changes or find bugs and report them. And it does have imprecisions. But it was rather a big piece of work of describing how museum data can be mapped. After that, this was followed by the Yale Center for British Art, and currently some aspects of it are followed by the American Art Collaborative. I'll mention that later. Conservation Space is a system for conservationists. So you capture depictions of an object before and after treatment, you plan treatments, you do record condition reports and so forth. It marries document management using Alfresco with Semantic database that's Ontotext GraphDB, and it also has something called Smart Documents, which are XML documents but with different renditions, and we tie up to the semantic classifications. It's a very nice project. It's led by the National Gallery of Art in Washington, D.C., with a good consortium of 7 or 8 other galleries. Next up is Europeana linked open data. So as part of the Europeana Creative Project, Ontotext created the Europeana Spark or EDM endpoint and the Europeana OAI server. So Europeana has always had that, the API, and we created these 2 other ways of getting the information. OAI is used if you want to get objects in bulk, whereas Spark is used if you want to find, if you want to write queries, statistical queries like on the right, or connections between objects and so on. This statistical query, it says give me all of the newspapers using the AT concept for newspaper, and find the date of creation and group them by decade. You couldn't do this with the Europeana API because there's several million, and it will just time out on you. But with Spark, it's quite simple to write this using group by and count and so on. Next up, the Europeana Food and Drink project. It was a rather enjoyable project, as you can imagine. I guess at project meetings we were trying to put more emphasis on the drink, not on the food. So as part of it, we created a semantic application. Sorry, there's a link to it. It's an open source application. Also, all of the data is openly available, and it can be queried, or you can grab the files and download them and load them in a semantic repository and play with it. Here's a screenshot from it. In this case, we have selected the provider Bulgariana. Ontotext also started this national aggregator in Bulgaria. We contributed about 9,000 Bulgarian recipes. And here we are searching for recipes involving beer. Turns out that there is 150 dishes, including pancakes. And here on the left, we see a breakdown by food and drink topic. I'll talk about this later. We also, turns out that we had in the Europeana food and drink dataset objects associated to Antarctica. So we're searching for place Antarctica, and there is 2 photos and 1 advertising from Captain Scott's expedition to the South Pole. This one here is that they drank a particular type of cocoa, so that's an advertising for that cocoa. And again, here you see a breakdown of the topics that appear in these objects by different categories. And Okay, how did we do a food and drink categorization or gazetteer? Well, we used the Wikipedia categories. If you start from the category food and drink, then you will reach almost 900,000 categories, or that's 80% of all. And most of them, like 99%, are useless. So this is a breakdown of the categories by popularity. In other words, how many articles each of them has. And the top here is food politics. If we look at categories that are 5 levels down from the root, it's oceanography and physical exercise and stuff that really is not about food and drink. And the reason for this is semantic drift. I guess I'll go about 10 more minutes. So the further down you go from the root food and drink, the more twisted the path of reasoning that leads to this target ontology. And the totality of these 900,000 ontologies, they have an average level of 16, and this really is not good. So we used some cutting, both manual and machine learning approaches, and by cutting down something like 300 categories, chopping off 300 branches, we got to a much better picture. The average level is 5, so that all of them are pretty relevant categories. And we have a selection of 17,000 food and drink categories, which includes 220,000 articles, and this is what we use for food and drink concepts. So, for example, here you would have foods like egg and onion and so on, and also 900,000 labels. So that's a pretty big gazetteer for that. Then we selected the second language in addition to English, and we picked French, partly because it has good overlap in the category 3 with English, so we could leverage the work on English, and partly because we had good content in French in that project. The next topic, how did we make the place facet in the food and drink application? Well, we used DBpedia and GeoNames to find place references. Unfortunately, it turns out that in DBpedia you don't have a good place hierarchy. You have it in Vicki Data, but at the time we decided to go with GeoNames, which has a uniform property for parent place. And because there is a co-reference between DBpedia and GeoNames, it was not hard to do that. So we only needed to add about 250 extra links. For example, Sloane Street, there is an object mentioning that, and there is a DBpedia resource, in other words, Wikipedia article about that street. We just added that it is in Kensington and Chelsea in London. And then we used the Elasticsearch connector for Ontotext GraphDB, and there you have it, a semantic facet of places. Now, once you have places, you can also do geographic mapping. We use the cluster mapper library. So we have, I think, 50,000 objects, 9,000 in Bulgaria, and you can click and zoom here and you see a breakdown of these clusters. But because all of the 9,000 Bulgarian objects, they are just linked to Bulgaria, therefore to one point, the center of Bulgaria, you couldn't see individual objects. So we introduced what I call jittering, random deviations, so you can get down to one particular object and look at it. I made a presentation once working with Wiki Data to try to encourage our data providers to work with this. So here, somebody contributed a photo of this particular Polish custom called Svečonka, and it's on Easter, some religious ritual, and it really is easy to add the information to Wiki Data and to add the photo to Wikipedia Commons. And when you have that, then we can discover that this photo is about Polish traditions, about Easter, and about food and drink, and show it appropriately in the classification. Okay, next up is an important series of projects that we did with the Getty Trust on the Getty Vocabulary Program, and I think this series of slides will be the last for me. So the Getty is a very well-respected institution, and these three vocabularies are very well known: art and architecture, thesaurus of geographic names, and union list of artist names. Kkona, which is about works of art, it stands for Cultural Objects Name Authority, is still in development. It's not as well known, but it's very important. It has the richest structure. Here you see the links between the thesaurus, and the dependencies really go like this. So AAT only refers to AAT, but for TGN, you now use AAT for things like place types. ULAN uses AAT and TGN. So in ULAN, you have things like birth and death place and other events. All of these refer to TGN. And then you have connections from ULAN out to VIAF. Well, first of all, let's mention the internal Getty systems. The Getty Museum, of course, uses this thesaurus for their cataloging. There is a Getty-wide search across all of their databases that also is organized along that. ATA is extensive bibliography on preservation and conservation. It also has subject items from this. On the other hand, you have the International Terminology Working Group, so different translations of the AT. The Dutch one, I think, is most advanced. It fully covers the scope of AT. You also have links to Library of Congress subject headings. Then, in yet another layer, you're going to have cultural objects referring to these data. So you now see the realization of that earlier diagram, the cloud of LOD. We first released AAT, and then TGN, and then ULAN. We're now working on Kkona and the Getty Museum data. And these releases have been highly publicized by no less than the head of the Getty Trust in a series of blogs. They're also widely used. I have a slide or two on that later on. Here, a very busy slide about the different sort of work that we did for the Getty, including contribution to the latest ontology ISO standard on thesauri, and including scientific papers on treatment of different kinds of broader relations and which ones can be composed and which ones cannot. We used not only SCOS, which is the basic vocabulary to represent thesauri, and also SCOS Excel to represent provenance of labels, but a whole bunch of other ontologies to represent things like sources, contributors, revision history, and so on. In addition, we created a specific ontology for the Getty stuff, Getty-specific stuff. Here's a representation of all the information that we captured from ULAN. So here in the middle is the concept or record, and it can have parent concepts in a hierarchy. It can have related concepts. These relations could have historic information and so on and so forth. The rest of that diagram, the label is the other busy class. So you have all kinds of flags about the label, the part of speech, is it singular or plural, and so on and so forth. I'm very pragmatic, so we did some of the work in Excel. Here we're mapping some key fields from a database to either a property or a class or a particular value from a small micro thesaurus. Or this is how we created, most of the Getty ontology. Most of it consists of relations between concepts and other things. So this is the turtle that we generate from really the curators fill out this table, and then we generate the semantic representation from that. This involved quite elaborate reasoning, and the reason is that we have custom relations called GVP, Getty Vocabulary Program, that uniformly capture the hierarchy between concepts in the in the node hierarchy. On the other hand, we have standard properties, goes broader and broader transitive, but for things that are not concepts, such as thesaurus arrays or other nodes, we have this new standard, ISO superordinate, ISO broader generic versus instantial versus partitive, and so on. So my point is that when you get down to semantic work with a particular rich data set, there is a whole bunch of details that it is important to take care of, to find proper modeling, to find applicable ontologies, and so on. I did a quite extensive documentation of this, and everything here is hyperlinked, and you can use it in a sort of semantic links into the documentation. We also did a whole bunch of sample queries, over 100, and a special integrated UI. So when you hover over here, there's a little button, sparkle, that appears. You click it, the query is copied in the top box. You can edit it and then submit it here, see the results, or just issue your own query. We also have full text search and a bit more features. Finally, about the Getty Thesauri, we have collected over 100 use cases together with the Getty. There's a lot more in this presentation by the project manager, the Getty. An example here is an application that you can use to fill out bibliographic metadata. Another example, the Getty is used in Europeana. So when this object type prints visual works is identified with the appropriate Getty URL, then you can reliably find all other paintings. Okay, final few slides of Ontotext objects. Currently working with the Getty Museum, and we're considering SeeDoc CRM, but maybe we'll also look at simpler ontologies. Of course, you cannot read this, but this is an example of the central thing in the system, a work of art. And here are little pieces of queries, and in brackets are field names. So I'm really hopeful that out of this we can generate the actual conversion scripts in the so-called R2RML language. Then I'm trying to convince Getty to make a contribution to Wiki Data. Wiki Data already has 480 paintings, but really the museum has 180,000 works of art. This is a query, and it shows an image grid of objects from the Getty Museum in Wiki Data. Wiki Data is very pragmatic and very strong effort to aggregate this data. The American Art Collaborative is a consortium of 14 United States museums that follow the lead of the British Museum and Yale Center for British Art. The YCDA is part of this consortium. So they're trying to model their data, SeeDoc CRM, aggregate it, and implement some applications over it. And some of the work is going on in GitHub, so you can see a lot of issues, and I'm trying to contribute with modeling ideas, diagrams like this, for example. So this is specific SeeDoc CRM modeling to capture the idea that for a sculpture, we're saying it is cast after the mold of another sculpture. Finally, I think the EHRI project, European Holocaust Research Infrastructure, I'm finishing a paper about this that was presented at the SeeDoc Congress. We're working in 4 different areas there, gathering information, converting it to EAD, and then semantic enrichment, formation of thesauri, going through oral history interviews and finding people and places and relations between them, really interesting stuff. So here is, for example, modeling for a person of networks, network of people, because one of the research cases that was formulated in the project is how the network of a person influenced the chance of survival. If you lived in a ghetto, what was the chance you would be deported versus you could flee away and stuff like that. We're doing large-scale data matching and data integration stuff. So, for example, the United States Holocaust Museum refers to, you see here maybe about 50 places, Ostrowiec, Ostrowitz, different kinds of spellings, but really it's always the same place. I mean, if you match it against geonames, and of course this needs to be checked, but most of them are the same place with different spellings. We did also some interesting experiments with the so-called words-to-vec algorithm. So if you look for the word guard after this processing and the cluster of other words with similar meaning, you see that all of this is pretty much relevant. So you go through the complete list of oral history interviews. That is maybe, I don't know, 250,000 pages of text. And then from the collocation of words, you can find clusters like this. It even allows semantic equations. Like if you say, what is KGB to, if KGB has a relation to Stalin, and what is the thing related to Hitler? And it answers, well, it is the SS. Again, discovering comes and ghettos out of institutional information that has a lot of duplication and variant spellings. Okay, I'm done with really the part that follows is projects by others. Some of them are very interesting. Take a look at them in the presentation that will be put online. And I think now it's time for the questions.
Thank you very much, Vlado, for this amazing presentation. Guys, please still stay. We still have a few questions that Vladimir will be answering. He will just take a look, and I just want to remind you that all of this is being recorded and you would see everything. You would receive an email together with this presentation, the questions, video recording of this, so you can actually hear Vladimir explaining everything that he's talking about today. Yeah, if you want to learn more resources about us, because I saw quite a few asking about this, we have a blog which you can visit on ontotext.com. You can check our previous webinars. We have a fundamental section which talks a lot about the basics of graph databases, what is text mining, etc., etc. So yeah, now Vladimir, you want to start answering some questions?
Yeah, but where can I read them? In the chat?
In the chat box and in your Skype.
Okay, I'll just look on Skype. Sorry. Okay, so if we have an existing software infrastructure, can semantics be applied for cultural heritage data? Yes, sure. That is most often what we do with clients. We don't purport to replace their existing systems. The whole point of semantic integration is to take data from different systems, also to leverage existing linked open data in that domain, and try to find connections and generate extra information. One thing that you may want to change in your organization has to do with enterprise thesaurus management, or some people call it master data management. So if the different departments of your organization use different values for the same things and different systems to maintain those lists, then we can deploy thesaurus management systems to do it in a single point and then feedback into your systems. Second question, can semantics and linked data help with multilingual data? And if yes, how many languages can we support off the shelf? Well, Europeana already leverages this by finding the AAT concept that corresponds to, let's say, an object type contributed by an institution, and maybe the object type is in German. But when they match it to AAT, they get 3 more languages, and they get a whole bunch more labels. So now you could implement a semantic search using autocomplete that allows all of these other labels to be used to find the object, and nevertheless you find all the objects that refer to that concept, no matter whether in German, in English, in Dutch, and so on. Vicki Date is especially powerful in this because it has labels in many, many languages. For popular things, it has labels in 200 languages. On the other hand, the question could be understood if we're doing semantic enrichment of text, in other words, going over free text and trying to find references to named entities, events, and so on. Well, Ontotext is strongest with English, not least because English has the largest amount of language resources, pre-trained parsers, part-of-speech classifiers, and so on. But we also have strong experience in Dutch, French, German, some in Italian, and also Bulgarian. And then the next question is about these 120 GraphDB rules that were used to implement several fundamental relations. The rules are rather simple. They are of the form, if you find such and such triples, then infer these new triples. That's all. And there is a detailed description of all of these rules in the research space conference that is hosted on the Ontotext machine. So in that link, if you remember the documentation of the British Museum mapping to CRM, that is a link to our conference. And if you search for FR implementation, you'll find the rules there. GraphDB rules are simple when it comes to rules. For example, you cannot do conditionals, you cannot do arithmetic computation, but this is on purpose because they allow efficient retraction of facts. In other words, when you delete something from the database, it looks for all the facts that might have been inferred by this one, and if these other facts don't have any other support, it goes and recursively deletes those other facts. And this is something that we call smooth delete, and no other repository supports it. If you want powerful inference with other repositories, it's either very slow or you have to do it once, but when you update your data, you have to redo it. Okay, are there any more questions? I see these three in the chat, in the Skype.
But we just, a lot of people left. I think it's best if we answer them afterwards and people would be more.
Okay. Okay, well, thanks everyone for your time, and we're looking forward to contacts if you think this kind of work is important. If you want to help in some of the crowdsourced projects, Wiki Date or DBpedia. For example, right now I'm starting to work on citations, bibliographic information. There's a lot of interest in libraries and publishers and Wiki Date about it. Or if you want to join this movement with data that you have, we'll be delighted to help and consult you. So bye for now.
Thank you very much, everybody, and thank you for joining us. Thank you, Vladimir, for this amazing presentation. If you guys need any more help or assistance, just write us at events@ontotext.com or just visit our website, give us a shout out or subscribe for one of our webinars. All the questions that have not been answered will be answered afterwards, so don't worry. Everybody who has asked will get an answer. Again, thank you for attending, and have a great day, night, or wherever you are in the world.
Bye-bye.